Hello, I am Pete Demar with Battery Research and Testing, and I will be narrating this session of our stationary battery maintenance tech tips, which is tech tip number 7, nodular corrosion. In this tech tip, we're going to explain the danger that nodular corrosion presents, invented lead-acid batteries, scroll through a few show and tell pictures, and then get to showing you how to perform a nodular corrosion detection inspection. It is well understood that while there are some very serious issues with all battery types, we primarily discuss lead-acid batteries of all types and designs in our tech tip sessions. These pictures here are from just a few of the rather serious incidents with lead-acid batteries which were caused by a variety of different issues. With most of these, the results were quite easily avoidable. Nodular corrosion is not necessarily obvious to an untrained eye. You will be surprised to learn that it is hiding right in plain sight. All you need to know is how and where to look to see it. And we're going to show you that here. We are sharing our knowledge on this subject so that those of you that perform the actual hands-on battery maintenance will know how to catch this problem in adequate time to prevent a catastrophic failure in your battery. Those of you that already know how to find nodular corrosion are amongst the 1/100th of 1% of the surface people around the world that know how to do this. My hat is off to you. Please contact us so that we can share interesting battery stories and knowledge. Nodular corrosion invented lead-acid batteries has been an issue that has impacted positive posts ever since they started installing covers on lead-acid cells. In other words, pretty much forever. The oldest paper that I personally am familiar with that explains the danger with the nodular corrosion issue in any detail is from Intellect 1988. It should be understood that this is not a new failure issue. It is just not talked about much. These drawings show where the nodules form on the posts. As you will see in pictures further along, this issue eventually changes the structure of the posts. The primary goal of all post seals is to keep the electrolyte inside the cell and to prevent it from getting up into the post seal well area and then out onto the cover, or from creating nodules on the positive post under the post seal. Whether it be the creep-type corrosion, which is seen on either the negative or the positive post, but primarily on the positive post, or the nodular type, which is only observed on the positive post, the cause is the same. The post seal failed to do its job. Post seal failure is not a subject that any manufacturer wants to openly discuss. A few do, however, explain in their marketing brochures how their seals work, and some even have a drawing of their design. Since they take the time to do this, it should be easy to understand that they consider it a very important part of their cell design. Even though the post seal is a critically important element in every battery design, no one explains why it is so important, or how drastic the results of a failure can be. This is demonstrated by the fact that not a single manufacturer in any of their maintenance manuals explains how to inspect their post seals. Also, sadly, there isn't any mention of this failure mode or how to inspect for this in any of the IEEE standards or recommended practices. This knowledge would be of benefit to anyone that either follows those documents or uses them as a guide with their maintenance practices. Remember, the goal of every battery manufacturer's post seal is to keep the electrolyte inside the cell and to protect the post from attack and the creation of nodular conditions. To all of us that have anything to do with maintaining stationary batteries, this makes obvious sense. As when electrolyte works its way up onto the covers or the posts or connections, it can lead to corroded connections or even paths to ground, neither of which is a good thing. Corroded connections, which are caused by creep corrosion, are mainly a maintenance issue, in that it requires time to neutralize and clean it. However, a corroded connection by itself, as long as it is not causing a high resistance connection, is not an issue that can cause a catastrophic battery failure. No way, it just cannot do that. This creep corrosion is observed as corrosion that will be on the post or connector, or by the blackening of the positive post, starting where the post comes through the cover, and eventually it will work its way up to the strap where it is bolted to the post. This creepage can also be noticed when you see moisture radiating away from the positive post seal area. This is the electrolyte, of course. The same lack of risk cannot be said about cells that have nodular corrosion. Nodular corrosion, if not detected and addressed, can lead to a complete failure of the post or posts under load. When you need it, is not a good time for a battery to fail open on you. This typically would not happen under a light load, but does occur in batteries that have a very high current draw when called upon, such as with power plant batteries. Take a moment and think about just what the result would be to your system or equipment if the AC power unexpectedly goes away and then your battery fails open before your system has time to reach a safe shutdown. The protective equipment for a typical power plant generator requires a substantial amount of inrush current to start motors and pumps and to activate other emergency equipment. Many of these loads are instantaneous in that they occur in just the first second or seconds of a unit trip. This is not a good time to lose DC power. In fact, that is a very bad time for this to happen. Take a moment and look at these two cells, both of which open internally while under load. Both were caused by a nodular corrosion condition. Which one do you think caused more damage to the site? Take your time and think about it. If you guessed the one that is ruptured open, you were wrong. Luckily, that one exploded when it was being discharge tested and it was offline at the time. Surely you were thinking, I see nothing wrong with the other cell. And you are correct. As I'm just looking at the outside of the cell, it surely is intact. It did not explode. The problem of nodular corrosion is not unique to any one manufacturer, as these cells are from two different manufacturers, years apart, and on two different continents. As you can see in the next two pictures, the positive post actually melted apart just below the cover. The top part of the post is still intact in the cover. You can see where the melted metal flash left burn marks. The opening of that positive post occurred when the generator that the battery was protecting tripped offline. Usually, the battery provides power to the equipment it needs to support, and the unit eventually spins down to a safe and non-destructive stop. The very key word is non-destructive. When the unit that this particular battery was supporting tripped, this cell opened instantly. And with no power to the lube oil pumps, the generator came to a screeching halt when the bearings melted due to the lack of oil. Think expensive here. This failure occurred in 2019, and based upon communication with the insurance carrier that was responsible for bringing us in to determine the root cause of the failure, the total loss when all was said and done and the plant was back online was a little over $8 million. Yes, that is correct. 8 big ones. Ouch! Okay, let's get to what it takes for you to find out if you have nodular corrosion or not. But first, some warnings. First, if you do not know how to safely work on energized battery systems, do not attempt this. Second, if you do not have the proper PPE in order to do this, do not attempt this. There are really only 3 requirements in order to accomplish this. The first being that the person doing this knows what to look for and where to look. The second is a flashlight. The third is a borescope. Our techs all have borescopes as part of their standard toolkit. These allow them to look into areas in cells that they cannot see from outside of the cell. We use the same scopes for either our vented or VRLA inspections. Just as a FYI, if you have cracked covers, then you already have advanced nodular corrosion. You will notice that the cracks will always radiate away from the positive post area. For these cracks to form, there has to be substantial pressure being created from the changes that are occurring to the positive post or post down below the cover because of the failure of that particular post seal. The very first warning of this issue in any cell will be the cracking or failure of the internal post seal in the cell. After it is well advanced, it then shows up on the cover on certain designs, but not with all designs. It cannot be emphasized strongly enough that with many of the cells that have the post seal designs where the post is coated and the post slides up through the cover, that the post can be completely decayed, as was the post in the cell that opened under load at the power plant, and there be no indication of anything wrong showing up on the cover. As you can see, when this problem is pretty advanced, it is easy to find. The majority of the pictures being shown here were taken in 2019 and 2020, but some are from before then. These are from different manufacturers with differing post seal designs, and all obviously had time to decay to get to these conditions. This does not occur overnight. It is a multi-year process. Some of these pictures are from strings that are less than 6 years old though, so it can occur fairly rapidly. In the very beginning, it is more difficult to find, but the typical clue will be a small crack, which usually starts at the bottom edge of the post seal well or of the post seal. As can be seen in one picture, there is just the very beginning of a crack, and in another, there is a stretching or slight rupturing of the post seal partway up the post, and in others, just a very slight crack up the side of the post coating. Cells which are quite lightly loaded as compared to their ratings can be pretty severely degraded and still be able to pass the currents that would be applied during a normal discharge or capacity test and not fail open. Because of this issue, we now recommend that anyone testing a battery that has a very high initial or inrush current in their load profile, that they perform either a service test or a modified performance test. Now let's get back to how to find these. Even if you have crack covers, which proves that you have nodular corrosion, you still need to perform a nodular corrosion detection inspection in order to understand just how bad your posts are degraded right now. First, you look from outside the cell with a flashlight and look at the area where the post comes up from the internal positive bust and goes up into the cover. You will notice there is a well area where the post goes up to. This is a space where the post seal is located. With battery designs where the post must be able to move upward as the battery ages, you will see that there is a coating on the post. That coating is there to protect the post from being attacked by the electrolyte. The electrolyte must not be allowed to get under that post coating, because if it does, it will attack and degrade the posts. With cells that are short and or the rack is not far off the floor, it may require that you lay on your side on the floor and work along the battery looking up into that area. And yes, there are some cells, because of where they are installed or the arrangement on the racks, you will not be able to see into the cells from outside of the cell. Such as cells that are against a wall or back-to-back arrangement on the rack. Just do the best that you can. After looking into the cells from the outside, you then need to remove the vent and insert your borescope into the headspace and look at the positive post seal area from inside the cell, obviously. It is important to look at as much as possible around the positive post. This opens up so much more that it cannot be overstated as to its importance. Take your time, as this is a CYA moment in time. Take pictures of what you see, as it is important proof of what you find. Our tech tips are not intended to be engineering, design, or scientific oriented. We are just trying to explain stationary battery issues in down-to-earth ways that any normal stationary battery technician can understand. If you would like to be notified when we release a new tech tip, please go to info@batteryresearch.com and tell us to notify you when we release a new one. Or if you just have a question on a stationary battery subject or issue, just do the same. Oh yes, if you have any experiences or pictures of unusual things that you have found, please share them with us so that all of us in this industry can benefit each other. Have a great day, stay safe and stay healthy, and thank you.